Welcome. I really like to think of today's explainer as kind of a detective's masterclass. We live in a world that is literally drowning in data and opinions, right? So we're going to look really closely at how valid knowledge is actually generated to solve complex, real-world mysteries. Whether you're an academic, an engineer, or really just someone who wants to clearly separate fact from fiction, well, you're definitely in the right place. We're going to crack open the investigator's toolkit and take a rapid-fire crash course in research methodology. Let's get into it.
Here's our roadmap for today. First, the quest for knowledge. Then, choosing your investigative tools. After that, we'll hit the step-by-step process, the researcher's code, and finally, making sense of data.
All right, kicking things off with Section 1, the quest for knowledge. I want to start off by asking you a really fundamental, almost philosophical question. How do we actually know what we know? I mean, think about it. We produce quintillions of bytes of data every single day, but how did the foundational facts of our modern world actually get there? They didn't just fall out of the sky, right? They were painstakingly extracted from the unknown.
And that extraction process, that's exactly what we call research. Now, research isn't just casually Googling a topic or, playing a hunch. It's the systematic investigation and study of a particular subject. It's this highly rigorous, evidence-based process that involves collecting, analyzing, and interpreting data. Basically, it's the deliberate vehicle we use to bridge the gap from the unknown to the known, really separating those hard facts from pure fiction.
Now, our motives for doing all this research generally fall into two main camps. Basic research is, well, it's pure curiosity. It's like discovering a weird new chemical property in a lab just to see what happens, without necessarily having any immediate commercial value in mind. Applied research, on the other hand, is highly practical. It takes that exact same property and asks, hey, can we use this to build a smartphone battery that literally lasts a week? So one expands the boundaries of human knowledge, while the other solves an immediate, tangible, real-world problem.
Moving right along to Section 2, choosing your investigative tools. Okay, so our first major tool is inductive reasoning. This is your bottom-up logic. Basically, you spot a pattern out in the wild, and then you build a broader theory around it. It establishes high probability, but, and this is absolutely crucial to remember, it doesn't guarantee absolute certainty. There is always a chance that the very next clue you find completely breaks your established pattern.
Now contrast that with deductive reasoning. This is the top-down approach. Here, you start with a broad, concrete rule and apply it to a specific case. Unlike the inductive approach, deductive reasoning uses strict formal logic. If your initial premise is rock solid, well, your specific conclusion is mathematically guaranteed to be true.
Let's think about the classic examples here. For inductive reasoning, it goes like this. All the crows I've ever seen are black, so all crows must be black. I mean, it totally makes sense, right? But one single white crow completely shatters your rule. For deductive reasoning, it's more like all humans are mortal. Socrates is human. Therefore, Socrates is mortal. If those first 2 points are absolutely true, there is zero wiggle room on the conclusion. And both forms of reasoning are incredibly valuable for making predictions and informing our decisions.
All right, Section 3, the step-by-step process.
So this is the chronological workflow of discovery. First up, you got to identify the exact problem because, well, you can't find an answer if you don't even know what you're asking. Then you review the existing literature so you don't accidentally reinvent the wheel. Next, you develop a master plan, head out into the field to collect your data, and then meticulously interrogate that raw evidence during your analysis to find the hidden meaning. And finally, you communicate the results. A brilliant discovery kept a secret helps absolutely no one, right?
Next up, Section 4, the researcher's code.
These are the non-negotiable laws that separate valid research from, frankly, reckless experiments. Informed consent, strict privacy, and the minimization of harm. These ensure that human participants are always protected. Add in absolute research integrity, meaning absolutely no fabricated data or plagiarism, and of course, disclosing any potential conflicts of interest. This level of transparency is the core reason we can actually trust the science that we read every day.
And finally, Section 5, making sense of data.
Okay, so once you actually have the data, you generally split it into two camps. Quantitative data is the how many. The raw numbers, statistics, and surveys that give you hard, objective facts to test your ideas. But qualitative data, that's the how and why. It's the open-ended interviews, words, and observations that give those hard numbers rich, real-world context. Think of it kind of like a restaurant review. The 4-star rating is your quantitative data, but that written paragraph complaining about the cold soup, That right there is your qualitative gold mine.
So you now understand the fundamental architecture of how human knowledge is systematically expanded. You got the logic, the workflow, and the ethical foundation down. So, equipped with this investigator's toolkit, what unknown variables are you going to solve next? The world is absolutely full of mysteries just waiting to be uncovered by a dedicated researcher. Thank you so much for joining me on this explainer, and hey, happy investigating!